Hello guys, let's check this very interesting problem, but it's a bit difficult problem to because you have to think a lot about it, how you can solve this. As you can see in the diagram, we have to find the area of the green square. So it's a square, that's the trick here. So let's try to solve it. So as it is square, let's say this length is, let's call it P, and this is also P. So what do you think about this length? Let's say this point is E and this point is F. How much will be AE and what will be the value of AE and FP? Are they equal or not equal? Because this is the symmetrical figure actually. If you look at A to C and from D to B, these are two circles, some parts of the circle, basically 1/4 of the circles with centers at A and B. If you complete this whole diagram from here, it will be a one big circle, and if you complete it from here, it will be another big circle with center at B, and this circle will have its center at A, right? So it's quite a symmetrical figure, and this is a square, so means symmetrical in the sense when we draw the two circles, the symmetry we see to the right of A will be the same as we see to the left of the B. So A should be equal to FP. Let's say A is X and FP is X, right? Only then it can be a square because of the symmetry of the figure. They both are like I hope you can imagine that this is the center of the circle and this is a circle, this is another circle whose center is here. Their radius are equal, and everything looks perfect here. So AE and FP should be equal. We can talk more about it in a different way also, but for now let's consider that these two are equal and equal to X. So what will be the length of AB? AB will be P plus 2x. Basically AE plus EF plus FP will be equal to 10, right? So this is one equation. Now what more can we think of? We need to have one more equation between P and X. Only then we can find the values of P and X. Only if we know P, only then we can find the area of square. So what I can see is this point is very critical. Let's join them. Now this is another right triangle. Let's say this point is called T. Now TB will be equal to radius of this circle, radius which is again 10, and TE is, we already know it's a square, so this is P, and this is X, this is X. So in this right triangle, let me write on this side, in right triangle TEB, I hope you can understand, TEB, this I'm talking about this right triangle now, right? So hypotenuse square, basically let's apply the Pythagoras theorem here. TB square is equal to TE square plus EB square. What is TB? TB is radius, which is 10. 10 square plus is equal to TE. TE is P square plus EB is P plus X whole square. Now this is second equation between P and X. We already have one equation. Now we can solve them, right? Let's simplify this. Let's take the left hand side to right hand side just to simplify. P square plus X square plus 2px. So this is the basic formula for, if you know this formula, A plus B whole square is equal to a square plus b square plus 2ab. This is the very basic formula of algebra. So using that formula, I'm opening the bracket. Plus p square is equal to 10 square is 100. Let's further simplify. Let's combine the like terms, p square and p square. 2p square plus 2px plus x square. Let's take the 100 to other side. Minus 100 is equal to 0, right? So this is one equation in p. From here we can put the value of x. X will be 10 minus p divided by 2, because we want to find p so as to get the area of square. Anyway, we can always find x once we know p. So let's put this value over here. So it will be 2p square plus 2p 10 minus p by 2 into x. No, x is, this is x, plus x square minus 100. Oh, x square also we have to replace with 10 minus p by 2 whole square minus 100. Sorry for this confusion over here little. So 2p square, 2 gets cancelled out, plus 10p minus p square plus 10 minus p by 2 whole square, which will be 5 minus p by 2 whole square minus 100 is equal to 0. So let's just expand this term. 5 square will be 25 minus p square by 4 minus 2ab, which will be 5p minus 100. Let's put the other terms, right? So this p square will get cancelled out, so we are left with only one p square. So p square minus, let me do over here so that it's clear. So p square minus p square by 4, this we took, and now 10p minus 5p will become 5p. I'm simplifying it. Plus 5p minus 100 plus 20, minus 100 plus 25 will be minus 75 equal to 0. So taking 4 to the numerator, it will be 4p square minus p square, which is 3p square by 4. Let's take this 4 also to the numerator for 5p, and let's take the whole numerator of 4. 5 into 4 is 20p minus 75 into 4 is 300 is equal to 0. This 4 goes away, so we are left with this equation. So this is a quadratic equation. Now we can easily solve it, right? How can we solve it? So 303, so which makes 900. Let me do those calculations here. So this is 900. What are the factors of 900? Let's see if we can factorize it, or we can directly use the formula for p. P is equal to minus b plus minus under root b square minus 4ac upon 2. This is a standard algebraic formula for any quadratic equation, right? So where b is this second term, a is the first term, right? Let me write the general form of the quadratic equation as well. Ax square plus bx plus c is equal to 0. For this general form of quadratic equation, this formula is always true. There will be two roots of this equation, provided this b square minus 4ac is positive, right? So let's solve one of the roots, minus 20, or maybe both of the roots. So b square is, this is b 400 minus 4 into 3 into minus 300, so it will become plus, sign will change to plus. 4 is the 12, 12 is the 36, so this will become 3600 here, 3600 divided by 2a is 6. So sorry, the calculations are getting messy. Let me just draw it here. So you can solve it. Minus 20 plus minus under root 4000 by 6. You can further simplify this, but this is the way to solve this problem. So I hope you understood how we have solved using two concepts of geometry and algebra. Also, you should know the roots, you should know this formula a plus b whole square, and then how to find the roots of a quadratic equation. So this was a very challenging problem. It checked your most of your concepts of geometry and how you can think, how you can go out of the box to think, and algebra and quadratic equations. So it's a very good problem. Yeah, thanks for watching the video. Any comments I would appreciate. I hope you learned something here. Thank you.